Welcome back everyone. So in the last video we solved insert, delete, get, random, and in this video we are going to solve product of array except self. So let's dive in. Okay, so we are given an integer array nums. Now we have to return an array answer such that answer at I is equal to product of all the elements of nums except nums at I. Now the product of any prefix or suffix of nums guaranteed to be fit in 32-bit integer. Now you must write an algorithm that runs in big O and time and without using the division operation. Okay, so let's see example 1. In example 1 we have 4 elements 1, 2, 3 and 4. Now the product of all elements except the first element is 24, product of all elements except second element is 12, and product of all elements except third element is 8, product of all elements except the last one is 6. Okay, so we have to do product of all elements except the element at ith position. Now we are also given, can we solve this problem using big O 1 extra space complexity, and the output array is not counted as an extra space. Okay, so we will solve this problem in 3 solutions. So the first solution will itself be this without using division operations. It is mentioned in the question that we should not use the division operation, but the first solution will solve using the division operations only. Okay, so let's understand example 1. So let's say we have the product array. Okay, so let's say we'll store the product of all these elements inside a variable product. Okay, so we'll have 1 into 2 into 3 into 4. Now we'll create an answer array, and inside that we'll store the product of all elements except that element. So at first position we'll store the product of 2, 3 and 4, that is 24. At first index we'll store the product of 1, 3 and 4. At second index we'll store product of 1, 2 and 4. And at third index will store product of 1, 2 and 3. Okay, so this is easy, right? But let's see an example. For example, if we have 1, 2, 0 and 4, then the product will obviously be 0. And if we try to fill this answer array, we'll get 0, 0, 0 and 0, which is wrong. Okay, so we'll have to modify our approach. So now let's say we have this example 1, 2, 0 and 4. Now what we'll do is we'll store the product of all elements except zeros. Okay, so we'll store product of 1, 2 and 4. Now we'll also store a variable which is 0 count. Okay, so we have 1 as a 0 count. Now we'll start with the first element. Okay, so if we take product of all elements except this element, we know that if we remove the first element, then in the leftover elements there is 1 0 count, which we can see, which means the product will obviously be 0. Now the second element, if we remove the second element and take product of rest of elements, we know that in rest of the element there is 1 0 count, so the result will be 0. In the third element we are at an element which is itself 0, so we'll first reduce the 0 count. Now we check. Now if we remove this element, okay, what will be the product? Since there is no 0 count, we'll have to check whether to divide this element with this product. Since the element is 0, we don't have to divide. Okay, so the total product is 1 into 2 into 4, that is 8. Now while going to the next iteration, we'll increment the 0 count once again. Okay, so 0 is again 1. Now we are at this position. Now if we remove this element and take the product, and if we take the product, we know that 0 count is 1, then the result will include 0 at this position. So this will be our answer. Okay, now let's see one more example. So let's say we have 1, 2, 3, 4, 0, 5, 6, 0 and 7. Okay, so we have product as 1, 2, 3, 4, 5, 6 and 7, and 0 count will be 2. Now if we remove this element, what will be the product of leftover elements? So we know that even if we remove this element, the rest of the element contain 2 zeros, so our product will be 0. If we remove 2, the leftover element still has two zeros. So 0. And if we remove this element, the leftover element has what? 0. So we'll write 0 here. If we remove this 4, the leftover element still has two zeros. So we'll get 0. Now we are at 0. And if we are at 0, we'll reduce this to 1. Now we see that even after we remove this 0, there is still one 0 left in the leftover element. So the product will still be 0. So now we increment again. Now we are at 5. After removing 5, we know that the 0 count is 2. So this will be 0. If we remove 6, 0 count is still 2. If we remove this 0, 0 count will be 1, still 0. If we remove 7, 0 count is 2, this will be 0. So from all these examples, we get one thing. If the 0 count is 1, okay, if the 0 count is 1, then one of the product might not be 0, okay. But if the 0 count is greater than 1, then all the elements will be 0 for sure, okay. So we have these two zeros in this array. Even if we remove this array, there will be one zero in the left out elements. If we remove this zero will be present, and if we remove this zero will be present. So whole array will contain 0 as the answer, okay. And if there is only one zero, for example in this case there will be only one zero, so all the elements except the position where there is 0 will contain the real product, okay. The product will be greater than 0, okay. So we can apply this optimization in our solution. So now let's implement this first solution. Okay, so first we'll take product as 1, and so we'll have 0 count as 0. Now for auto n of nums, we'll do product is multiply equal to, if n is not equal to 0, then product will be with n, else 1. Also z count will be plus equal to not n. If it is 0, z count will increase. Now size will be dot size vector of int answer of size. Initially all the elements inside this answer will be 0. Now for I is 0, I is less than sz, I plus plus, goal will check if this element is 0, okay. If this element is 0, we'll do num set I is equal to 0, and z count will decrease if this element is a 0 element, okay. So is 0. Now if the 0 count is 0, there is no 0 count, then we'll have to answer at I is equal to product of all the elements divided by this element. Now the element we are standing on can be 0. The element we are standing on is 0. We'll divide by 1, else we'll divide by num set I, and that will be assigned to answer at ith position. And now when we are moving on to the next iteration, we will restore the 0 count plus equal to is 0, and finally we'll return the answer. Now let's see if this works or not. Okay, so our initial test case has been passed. Now we'll see if this can pass all the test case or not. And our solution got accepted. Now we will apply optimization in this, okay. So we have this 0 count, okay. And if we check 0 count position, so z count position is -1, okay. So we'll remove the 0 count instead, and we'll keep 0 element position. So initially it will be -1, there is no 0 count position. Now if we check if this element is 0, okay, now is 0, but if the z element position is not equal to -1, which means there is already a position assigned to z element position of the 0 element, which means there is at least two zeros in this array, which means all the element will be 0 in the final answer. So we'll take these two lines at the top, and in this situation we'll return simply answer. Else what we'll do is we will do z element position equal to I. So now we'll start, int I is 0, I is less than sz, and I plus plus, and int n is num set I. Okay, so z element position is this element. So we have checked for the duplicate zeros. If there are more than one zeros, then this if condition will execute and will return the answer. Now at line number 18, either we have one zero or we don't have any zero. And if we don't have any zeros, then we'll execute this loop. Okay, we'll remove these zero count things. So if there is no zero, then we will execute this loop. So the answer at I will be product of all the elements divided by element at that position. But if there is a zero, let's say if there is a single zero, so if z element position is not equal to -1, then what we will do? There is only single zero, okay, and the rest of the elements will be something, for example 1, 2, -1, -2, anything, but it is not zero. So the position where the element is 0 is the only element that will contain the real product. All the elements except that will be 0. So answer at this z element position will be what? Product, right? And we will return answer. So now let's see if this works or not. Okay, so our initial test case has been passed, and now we'll submit this, and our solution got accepted. So just to recap the approach one, so in this what we did is we first take the product of all the elements which are not 0, okay, and we also created a variable for z 0 element position. So now we traverse from 0 to the sz. Now in that we'll take the product of only elements which are not 0, and if the element is 0, okay, we check if there is other 0 whose position we know, and if there is another 0 whose position we know, which means that this array contains two zeros. In that case the whole array will be 0 no matter what. So we'll directly return from here this answer array which contain initial 0 in all the position. Okay, now if this is the first 0, then we'll give this element position I, that at this position there is a 0. Okay, now at line number 17, we have either there is only single element with 0 or there is no element with a value 0. Now we check if there is an element with a value 0, and if there is an element with a value 0, then that is the only position which will contain the real product. So at that position we assign the whole product and return the answer. But if we are able to reach at line number 22, then the array does not contain any 0. In that case we have to assign the product to each position. So at each position the product will be product divided by the element at that particular position, and will return the answer. Okay, so now we'll see the next approach. So first let's see the follow-up. So in that it says that can we solve the problem in big of 1 extra space complexity. So this will be our third approach. So second approach will be we'll use the prefix and suffix array. So it also says that the product of prefix and suffix of nums is guaranteed to fit in 32-bit integer. So it's giving us an hint that we can use a prefix array and suffix array to solve this problem. Okay, so now let's see example 1 using prefix and suffix array. Okay, so we have one prefix array and we have suffix array, and finally we have an answer array. So first we will pre-fill the prefix and suffix array and then the answer array. So prefix, so at the ith position in the prefix array we will get the product of all elements until the ith position. So at 0th position we have product of all element until 0th position. So here it will contain 1. At the first position will contain the product of these two elements, that is 2. At the second position we will have product of all these elements, 6. And at the position 3 we have product of all elements until this position. So we have 24. Now in suffix we'll start from the right side. So at this position we have product of all elements from that position to the last position. So at this position we have product of these elements 4. At this position we have product of these two elements 12. At this position we have these three elements 24, and at this position we have product of all the elements, that is 24 again. Now what will be the answer at 0th position? So this is our array 3 and 4. Okay, so we want the product of all elements except this element. So if we calculate the suffix and the prefix and multiply both, we'll get the result, right? So at this position the prefix will be this and suffix will be this. So prefix will be 1 and suffix will be this, that is 24. Okay, so now at this position the suffix will be this element and the prefix will be this element. Okay, so it will be 12 into 1, that is 12. Now at this position the suffix will be 4 and the prefix will be 6. Sorry, the prefix will be 2, right? So it will be 4 into 2, 8. Now at the last position the suffix will be 1 and the prefix will be 6. So we'll have 6 as the answer. So now let's see one more example. So let's say you have 1, 2, 3, 4, 5, 6 and let's say 0 here and 6 here. So we have prefix, suffix and answer. So in prefix it will be 1, then 1 into 2, 2, then 6, 24, 120, 0 and then 0. Okay, and suffix will be now 6, 0, 0, 0, 0, 0 and 0. Okay, so the answer will be, so let's say these are indexes 0, 1, 2, 3, 4, 5 and 6. So for 0 index the prefix will be at this index and suffix will be at index 1. So that is 1 into suffix at index 1, that is 0. So it will be 0. Now at first position the prefix will be at 0 and suffix will be at second index. So prefix at 0th index is 1 but suffix at second index is 0. So it will be 0. Now at second position the prefix at first position and suffix at third position will be 0. Now at index 3 prefix at 2 and suffix at fourth position will again be 0. At fifth the prefix as 3 and suffix at fifth position will again be 0. Then at position 5 the prefix at fourth position and suffix as sixth. So at fourth position we have 120, okay, and suffix at sixth position will be 6. So this will be our answer here. Now at sixth position prefix at fifth position. So prefix at fifth position is 0, 1, 2, 3, 4 and 5, that is 0. So product will be 0. So this is our answer, which is 0, 0, 0, 0, 0 and 0, 2, 7 and 0. So this will be our final result. So all these elements will contain 0 and at this position the product will be product of all elements except this 0, and that's why we have 720. Okay, so now let's solve using this approach. So we have two arrays, prefix and suffix. Okay, and if there is no size, we'll simply return answer, else the suffix at last position will be nums at last position, right? And prefix at first position will be first element. Now we'll start for the prefix. I is 1, I is less than n, I plus plus. So prefix at I is prefix at I minus 1 multiply nums at I. Okay, so prefix of the previous element multiply this current element will give us the prefix for this ith element. Now similarly for suffix, so in suffix case we'll start with n minus 2 because for n minus 1 we already did, and from n minus 1 n minus 2 greater than equal to 0 minus minus, so suffix at I is suffix at I plus 1 multiply by nums at I. So suffix of element that is next to it multiply the current element will give us the suffix for this current element, right? Now we'll do for the answer. So int I is 0, I is less than sz I plus plus. So answer at I will be what? Suffix for the next position and prefix for the previous position, right? Now the I plus 1 can be out of the bounds. In that case we'll use 1. So if I plus 1 is greater than or equal to sz, in that case we'll use 1, else we'll use suffix at I plus 1. Now I minus 1 can be, for example, minus 1. If this is less than 0, we'll use 1, else we'll use prefix at I minus 1. And finally we'll return answer. So let's see if this works or not. So let's say n. Okay, so our initial test case has been passed, and now we'll submit this, and our solution got accepted. Now we can merge these two loops. So let's see how. So we are assigning prefix. Now for the suffix part, we have this. So since I is 1, we have n minus 1. This is the last element, and minus I, this will give the last second element initially. So we'll use n minus 1 minus I, okay, plus 1. So it will be this, and this will be n minus I, okay. So the last second element will be the next element, that is n minus 1 minus I plus 1. So this will be n minus I only. So suffix at n minus I plus the current element, that is n minus 1 minus I. So that will be suffix. So let's see. Okay, so our initial test case has been passed, and now we will submit this. Okay, so our solution has been accepted. Okay, so now let's understand third approach using the first example itself. Okay, so in the previous solution, we had maintained two arrays, that is prefix and suffix, and then finally answer. Okay, so if we want answer at ith position, we will use suffix after that element and prefix before that element, and we will multiply this to get the answer. Okay, now let's see how we'll solve this without using an extra arrays, that is prefix and suffix. So we'll have prefix. So now in this, there is change in the definition of prefix, how we calculate prefix. So the prefix will be product of all elements before it. So at this position, the prefix will be product of these three elements, that is 6. At this position, it will be 2. At this position, it will be 1. And at this position, since there is no elements before it, it will always be 1. Now we will turn this prefix array into the answer array. Okay. Now let's see how. So we are at this position, right? And we will maintain a suffix variable that is initially 1. Now we are at this position, and what do we have? We have 6. And what is this 6? This 6 is product of all the elements before it. And to get the answer at this position, we want the suffix of all the elements ahead of it. Okay. So when these two are multiplied, we'll get the answer, that is 6. Multiply this suffix, that is 6. And now while moving from this position to this position, we will multiply suffix with the element at current position, that is 4. So 4. So now suffix will be 1 into 4. So suffix is this element. Okay. Now we are at this position. This position gives us product of these two elements. Okay. So we have this prefix, and suffix will be all the elements after it. That is this. We already have, that is 1 into 4. So we'll multiply 2 into suffix, that is 8. So the answer at this position will be 8, and we will multiply suffix with this 3. Now we are at this position. So prefix at this position will be this element. Okay. We are at this position and prefix is this. So this element tells us the prefix because this is prefix array. Now the suffix will be these elements. Okay. And we already have this, that is 4 into 3, and we will multiply this, we will get 12. Okay. Now while moving from this position to this position, we will multiply this 2 here. Now at this position, we have product of all element before it, that is these elements, which is 1, and suffix will be all these elements, that is 4, 3 and 2 and 1, that is 4, 3, 2 and 1, that is 24. So we have the result as 2, 4, 12, 8 and 6. So this is our array. So at this position we'll have 4, 3, 2, 24. At this position we'll have 12. At this position we'll have 8. At this position we'll have 6. So that's our answer. So what we did is we turned this prefix into answer itself. So first we calculated the prefix. Okay. Then instead of calculating suffix, we calculated suffix inside a variable. So we traversed the prefix from last position. Okay. And from last position we keep on creating suffixes. So our prefix and suffix are merged and finally it is turned into answer. So we optimized the last solution to not use any extra space. So we calculated both these without using prefix and suffix. Okay. So now let us write this solution. Okay. So we have this answer. So we'll use answer as a prefix also. Let's fill up our prefix array as a prefix array. So prefix, that is our answer itself. Okay. So prefix at the ith position will be prefix of the previous position multiply prefix at the multiply nums at I minus 1. So the prefix of ith position will be product of all elements before it. And if we take the prefix of previous element, which means the previous element will give product of all elements previous to that element, multiply the previous element, which will give us the prefix for this current element. So we have filled our prefix array now. Now after filling this prefix array, we will traverse from last. Okay. So from last, we also maintain a suffix variable, which will be 1. We'll start with last position greater than equal to 0, I minus minus. So for last position, we have answer at this position will be prefix at this position. So prefix multiply by suffix, and suffix will now will be nums at I, and finally we'll return the answer. Okay, so we got the wrong result. So let's see why. So we took the size, we created this answer array, and if there is no n value, we'll return the answer. So if I is 1, I is less than n, I plus plus, answer at I will be answer at I minus 1 multiply nums at I minus 1. Suffix will initially be 1 for int n, I is n minus 1, I is greater than equal to 0, I minus minus. Answer at I will be answer at I multiply suffix, and suffix multiply equal to nums at I, and we will return answer. Let's see what's wrong with this. So we are getting always 0. Okay, and I know why, because answer at 0 will be 1 always, because answer is a prefix array initially. So the prefix of the first element is product of all elements before it, but since there is no element, the prefix of the 0th element will be 1. And now let's see. Okay, so our initial test case has been passed, and now we will submit this. And our solution has been accepted. So just to recap, what we did is assume this is our prefix array. So prefix of first element is 1. Now for all elements, we'll calculate the prefix. So prefix of the ith element is the prefix of previous element multiply the previous element will give us the prefix of this current element. Now we have prefix. Now in this, we'll start with the last position. So from last, what we have for last element, the prefix of the last element multiply the suffix. Since we are at the last position, the suffix will initially be 1, right? So this is just the optimization over the last solution where we used prefix and suffix as a two separate array, and in this solution we use prefix and answer all in single array. So we reduce the suffix to a single variable. Okay, so that's it.